Hi, welcome back to .NET Conf. My name is Barry Dorrans. I am the security PM for all of .NET. So today I'm going to talk about security, and specifically the security that comes with ASP.NET Core. Some of the enhancements that we've done from 1 to 2, some of the enhancements that we did when we threw everything away and moved to 1, and then it's a sneak preview of what we're thinking about for 2.1. So I'm going to talk about hosting your application securely, then how we authenticate your users, then how we stop your users getting to places they don't want to be, and then we'll finish up with how you can protect your data. So we'll start off with hosting your application securely. When we threw everything away and moved to .NET Core 1.0, we decided that we wanted a cross-platform web server. A web server, as you can imagine, makes security people very nervous and vulnerability testers very happy because it's not a challenge they get very often. So in 1.0, we decided that, well, the web server's sort of there, but really we should run it behind IIS if you're on Windows, or Nginx if you're on Linux. And we recommended that you did not run Kestrel on its own and expose it to the internet because it just wasn't that ready for that type of abuse. Now, in version 2, we will support you if you expose Kestrel directly to the internet. There are a bunch of configurations for security around timeouts, so you can tweak how Kestrel runs and how it reacts to certain types of attack. We've chosen what we feel are sensible defaults for all of those. We've built in HTTPS support because, let's face it, no one should be exposing a website on the internet now unless you're running it over HTTPS. But we still recommend a proxy, just for that extra layer of security. But if you need the speed, the configurability of Kestrel, feel free to expose it to the internet and we will support you if things go horribly wrong. So when we're talking about configuring Kestrel for security, we have a bunch of timeouts, as you can see on the slide. There is absolutely no way I'm going to read all of those out because it would be very boring. But those will enable you to tweak and help protect Kestrel as it is exposed to the internet. So there's hosting out of the way. Nice and simple. 1 minute, we're done. Authenticating your users. This is where it gets slightly more interesting. In ASP.NET Core, we have a bunch of template support. When you do File New Project, you can choose to have no authentication whatsoever. You can choose to have individual user accounts, and you can store those within your application, within a database that you have to manage, or you can use Azure B2C. We have work and school accounts, which is using Azure Active Directory. And then for people who are still on intranets in a Windows-only environment, we have Windows authentication, that magical authentication that means you don't have to log in at all, and we just know who you are because you're logged into your PC. We also have a bunch of social authentication mechanisms. We have Facebook and Twitter and Google and Microsoft account. And there is a community-driven project, you can see the URL on the slide, that has lots of social authentication providers, including things I have never heard of. I'm sure there's probably a social network for people in Antarctica in there somewhere. If it's a social network, someone has added it into that project. So from template options, we have our individual user accounts. This has a local database. It uses EF for everything. It gives you models for your users, for your accounts, for groups, for roles. You can pick and choose what you want. You can edit the model so you can add more properties to your users. But we're quite opinionated about the security side of things. You don't get much choice in how we store passwords. You don't get much choice in how we encrypt things or we don't encrypt things. But you can override them if you want, but our opinion is what we're giving you by default is probably the safest for now anyway, because encryption always gets broken, hashing always gets broken. So when new versions come down, if we change the hashing algorithm, we will do a sort of update mechanism. So when your users log in, we'll rehash their password with the latest and greatest and safest hashing mechanism. Then we have OIDC, which is an open standard for authentication. This is what we use for our work and school accounts, to Azure AD, and for a bunch of our social bits and pieces. So Google supports this, Facebook supports this. And because it's a standard, you can pick and choose. You can just point it at anyone that obeys the standard, and it should magically work. Those of you that are thinking about porting some older applications and that have had to use governments and banks and other slow-moving partners are probably looking for WSFed support. WSFed was one of the original federated standards. There is no support in the box for that yet. You will probably see it in about a month and a half. So if you are binding to government, if you are talking to banks, if they want to federate with you and they say, no, we're not doing OIDC because it's new and exciting and we're banks or governments, so we don't do new and exciting, you will have WSFed support pretty soon. And obviously, Windows authentication, it needs to have IIS. So that means you need to be hosting on Windows. And for proper Windows authentication throughout a domain, your IIS server needs to be domain joined. One difference that we made from previous versions of ASP.NET when we moved to Core is there is no automatic impersonation anymore. So it used to be you could set a flag in your web.config. So when someone logged in, that entire process would run as their login account, their domain account. Now that's debatable from a security point of view, to be perfectly honest. So what we're doing now is we are going to make you do manual impersonation around those things that need impersonation. For example, database access. So you can take your user class, you can call impersonate on it, and then when you're done, you just turn the impersonation off. When we switched from the .NET Framework to ASP.NET Core, we got rid of custom identity classes. Everything now is claims principal based, so claims principal and claims identity. We have multiple authentication middleware in ASP.NET Core 1, and you could choose to run ones automatically, or you could choose to run ones only when you decided to programmatically. So you could have two endpoints in your application, one of which would be protected by cookie authentication when you're logging in through a form, and another one that could be protected by bearer authentication if you were sending a JWT token. Only one of these middlewares can be set to run automatically. That was our intention. You could actually set multiple ones to run automatically because we didn't architect it that great. And when you did that, you would end up in what was described as an unsupported scenario, which is a pleasant way to say, we have no idea what's going to happen right now. We have fixed that in 2.0, and I'll come on to that. And for those of you who are using cookie authentication and were irritated with us in the .NET Framework because we did not understand the difference between unauthenticated and forbidden, we finally added that in .NET Core, which normally gets a cheer from an audience when there is actually an audience. So, because we kind of messed up the architecture in Core 1, we changed things a lot. When you move to Core 2, you will see that authentication is now a single service. There is no more individual authentication middleware. You add to this service. And so we can now enforce the fact that there is only one active authentication service. So you can't get into that mixed up, unsupported scenario again. We also finally got around to adding QR codes and TOTP for authentication. So if you have two-factor authentication, you no longer have to use text, because using text and SMS for two-factor authentication is an incredibly bad idea these days. If you've been watching the security news, you can see that a lot of people have had their mobile phone taken over through various vulnerabilities in the mobile phone networks or social engineering of the mobile phone platforms and their support people, and have had all their Bitcoin stolen. So if you are looking at using two-factor auth, we will now support authenticator apps. We are using the TOTP standard, so you don't have to use the Microsoft Authenticator app if you don't want to. You can use Google's one. And we will get the QR code up, and you can pick up your phone and you can scan it. So let's take a quick look at that. I will hit run, and you can see my wonderful UI skills for demos, which basically consist of editing the templates and not trying to do anything fancy. So when this eventually starts, you will see that we have just a normal ASP.NET template website. So I'm going to log in. And I'm going to log in as me if I can remember what I set my password to. And away we go. And if I go up and look at my profile, there is now an option for two-factor authentication. And if I choose Configure Authenticator App, you can see that we have the standard sort of TOTP flow that you would see. We have a QR code that you can scan in on your phone. Now, we don't distribute a QR code language with our QR code library with the templates, but we give you instructions so you can choose your own, and we have some recommendations of ones that you can choose, or you can use the own one that you have written. And then, if I scan this in my phone, I can type the verification code in, and lo and behold, I will now be protected by two-factor auth when I do my logins. Nice and simple. So if you're moving to Core 1 rather than Core 2, this is how we configure authentication. We're going to use app.use and then the authentication type, and then we have a bunch of options, and I can add another one and chain them on so and so forth. You will see that we have automatic authenticate and automatic challenge. Only set automatic authenticate and automatic challenge to true on one of your middlewares. In 2, it has changed. If you are migrating from 1 up to 2, this is what you will have to do. You will have to add authentication in Configure Services, set your defaults for the authentication service as a whole, and then you add cookie, and you can set all your options for cookies, or you can add bearer, and so on and so forth. And in your configure function, you just do app.use authentication. So you need to do both. If you don't add app.use authentication, nothing authenticates. When you configure authentication in 2, because we've made this a lot harder to mess up, you now have like 4 different places where you can plug in what service is going to be used. The default scheme is, well, I only have cookie middleware, so everything can go to cookie, but you can swap between the service that you use to authenticate, the service that you use to sign in with, and the service that you use to challenge. So here again, we have a comparison between 1 and 2. So for those of you who are migrating, and I strongly recommend that you do, we can see the difference. If you are doing things manually, you used to call context.authentication.authenticate, and now it's just context.authenticate. And if you try and compile everything in 2, you will get a bunch of obsolete warnings with a link to a page that will tell you where you need to go and the different namespaces you need to swap out and how you need to change your code. Lots of people want to do everything themselves. They may not like our identity solution. So it used to be really poorly documented in the days before Core of how you could use some of our components to support your own code. But we've documented it. And now you can just use cookie authentication to support you when you're writing your own backend database, your own login flow. And the reason I'd recommend this is that we are going to do encryption and signing and protection of your cookies for you. You don't have to think about this. It just magically works. And we will support this across multiple servers. We use a data protection layer, which I'll come on to towards the end of the presentation, but you can share your encryption keys between multiple machines in various ways, and it will all magically work through load balancing. And you can use the cookie middleware to serialize your own claims identity that you've constructed via whatever mechanism you want, and authenticate subsequent requests. But there are a few caveats for this. Once a cookie has been dropped from the cookie middleware, it is the sole source of truth. We do not go back to your database automatically because that would be really expensive. So you need to plug in a validator if you want to do this sort of thing. And validators can look at a principal, they can change it, they can replace them. So you can add like new roles if you're changing it in an admin panel, and the user will automatically get refreshed. And it runs on every request. It's up to you to decide what your caching mechanism is before you go back to your database and how that gets cleared. Identity uses this to support changes in a database, and it checks every 5 minutes. So I'm going to quickly have a little demo of how to bake your own cookies. and how to use the cookie middleware on its own because it's important to a lot of people. So if we switch back to Visual Studio, and I set my startup project, excuse me, the rain has started in Seattle, so of course now colds settle in. So here we have in our configure services, we have our adding authentication right here. And then I'm adding the cookie middleware and I'm setting some paths and I'm going to wire up a validator. And because we remembered to do it, down in configure, I am going to set app.use authentication. So I'll go to my controllers and I'll go to my account controller. And here I am just going to create an identity and then use the cookie middleware to store it away, encrypted and signed, so no one can tamper with it. So I call HTTP context, sign in async, and I pass in my user principal, and I say when the cookie is going to expire. And I'm passing in an authentication scheme. Now, authentication schemes are a way of identifying each of the services underneath your authentication middleware or your authentication service. So each of the types. So you can have multiple instances of the cookie authentication pieces if you want. They just have to have different schemes. But for simplicity's sake, in this one, I only have a single scheme. And to show how validators work, we will go back to startup. You can see that in my events for my cookie authenticator, I am going to add a cookie validator via the onValidate principal event. And here is a simple cookie validator. And what it's going to do, it's going to keep track of the number of times that an individual identity has visited a website. And then eventually it's going to go, that's enough. And I'm going to change the name. I'm going to increment a number within the identity. So we'll run this because it's very exciting and you get to see my lovely UI skills, which are even less than they were before. So there's going to be no login page. I'm just going to write an identity out immediately because I don't need that. So I have hello Barry because my identity is Barry. And this number up here, well, that's the number of times that I have hit my validator and done a refresh. So I'm not going to do this on every request. So there's one request, there's two, there's three, there's four. Oh, and there we go. So it's ran over. So those were 4 extra requests to my initial one. And if we go back to the validator, we can see that the validator will increment the name to have this number every 5 requests. So let's go back here. Oh, there we go. Scene count, I've seen him 5 times. Therefore, I'm going to reject the principal. I'm going to force someone to, I'm going to log him out. And then because I have the principal automatically being created in my login page, I log in again, and I'm keeping a running count in my little login stuff. We can hear this is the number of times I've been issued, and I'm setting my name to have the issue count. So I've rejected a principal. You can replace a principal, so you don't have to force someone to go through login. You can use this if you have an administrative page, like I've said, you've added someone to a new role, and then eventually when your validator kicks in and gets past all your caching mechanisms, you can refresh their identity without having to log them out. So you can use all our bits and pieces. You don't have to be stuck with our identity system. You could just have a straightforward form. Of course, you would never hard code usernames and passwords because that would be an incredibly bad idea. And don't store them in text files either. If you are going to do these things, make sure you are doing them properly. There are a bunch of standards for this stuff. Don't encrypt passwords. Make sure that you're hashing. Make sure that it's salted. Make sure that you're using a strong hashing algorithm. These are the choices that we make for you in identity. If you're doing it yourself, you're going to have to make those choices yourself. And you're going to have to keep them up to date. So it's a choice for you. Do you want to roll your own stuff and have all that stress? Or do you want to use identity and be constrained by our opinions? So like I said, we can have multiple ways of logging in. We can have cookie, we can have bearer tokens if you're using Jot, we can have AAD, we can have Google, we can have Twitter, we can have Facebook, we can have this mythical Antarctic social network that I'm sure is actually probably down there. So how do you choose which one you want to authenticate with? Well, when you hit a controller that needs an identity, you put the authorize attribute in it. That has not changed from previous versions of the .NET Framework to Core. But what you can do is you can choose the scheme that you want the user to be prompted with, that you want the identity to be sourced from, and then everything will take over from there. And you do that by specifying the active authentication schemes. It can be multiple. You could have bearer and cookie if you so desired. And then the identity subsystems will go and ask each of those instances with that scheme name, have you got an identity? If not, kick in and do your auth bits and pieces. What is coming next? In 2.1, we are looking at identity as a service. So I talked about OIDC, which is the standard for federated identity these days. There's been a bunch of things. We've had OpenID, we've had OpenID Connect, and we've had WS-Fed support years and years back. So we're thinking of changing slightly the way ASP.NET works, in that we will be using OIDC for login flows. This means that you can add identity support for your mobile apps, for your native apps, for your SPA apps, without having to worry about cookies and CSRF and how you get a JOT token and all that sort of magical stuff that we have never really gotten to before. And the nice thing about this is, because we're going to use the same standards, you can swap it out. If you want to start off when you're initially developing your app and you're fine with a local database, then you'll have app.use identity service, which is a poor name and will be changing. But if you don't like that, you can swap out. Just comment that line out and use app.use Azure B2C or Identity Server or OpenEdict or ASOS or any of the third-party identity services that are out there. And then, like I said, for those of you that are stuck with governments and banks, WS-Fed client support will be coming pretty soon. You will probably see it before you see 2.1. So I want to demo identity as a service, and this is one of those demos where I have to keep my fingers crossed, because I have basically cloned the identity repo, made sure I have the right daily build of the runtime on my machine, and then I'm going to run the test websites and WPF applications that we have. There are days where this works, there are days where it doesn't. So I took a rubber chicken and sacrificed it to the demo gods, and we will see how this goes. This is why I have the update your Visual Studio flag up here. There is absolutely no way I'm updating Visual Studio right now because it may disturb the daily build. So bear in mind, this is our integration test. This is an ugly website and an ugly WPF site as well. So it's just taking a little bit to start up. So I'm going to click sign in. And then hopefully when it kicks in, you will see that the URL here is an awful lot longer than it used to be. This is because we're now doing OIDC. But there's nothing really changed from a user's point of view, or indeed from a developer's point of view. I'm going to log in. And it's exactly the same flow. I'm still me. But if I go to my WPF app over here, and we'll just zoom in on this, we can see that it's got a bunch of debug information. So I'm going to hit authorize, and it should pop up the typical OIDC login. Now, this is debug, so pay no attention to the red bars. This is just trying to help us do layout and stuff like that. But I can log in. Oh, I've got myself confused. I can't remember my password. I was about to say it out loud. That would have been embarrassing. So it has authorized. Now, this is a test app. So here we go. At the very bottom, you can see that it now has my email address because that's what I've logged in with, which is great. I'm using open standards. I'm using OIDC to talk to an identity backend. Identity for us is just the backing stores and the classes around it. We're now using our open standard protocol, and I can quite happily use a WPF app. I can go over here, and then if I do a SPA app, I'm going to hit login with my SPA app. And this has all been done via the magic of JavaScript. And I have logged in because I already have the cookie. And you can see that I have logged in. And I can call a web API. I can send a JWT token back again. So you can see that there is some test code here that is telling me what is being sent. It's all very exciting, but not very pretty to look at. So this is where we're planning to go, hopefully in 2.1. There are a bunch of other stuff coming around with it. We'll have HTTPS certificate creation. We're going to create signing certificates for you and show you how to manage them. But remember, if you don't like identity, you can swap it out. You can swap it out for identity server if you have an identity server federation setup done already. If you don't like identity server and you want Azure to take care of it, you can swap it out to Azure B2C. You can swap it out for Azure Active Directory. It's just simple because now we're using the standard flows. So we've now got a user's identity, whether it's the old way or the new way. So we're going to talk about how we control access, and this is authorization. Lots of people try to extend authorization in the .NET framework, and it was not a pleasant experience for anyone. You would have to write a custom authorize attribute, which normally went horribly wrong, or would end up being insecure, or would throw weird exceptions and cause your application to crash. And we didn't like that. We wanted you not to have to go through that pain anymore. So we have switched how authorization works. Authorization is now all in code. You don't have to write an authorization attribute anymore. In fact, the authorization attribute is just a marker. If you subclassed it, if you wrote your own, nothing would happen because there's no code there. Instead, everything is done in code. We have the concept of authorization policies. Authorization policies may have one or more requirements, and each of those requirements may have one or more handlers. No, this may be confusing, but when I do my magical demo, it will all make sense, I promise. We also have resource-based authorization. Resource-based authorization allows you to go a little bit further and imperatively query whether a user can access something or not. If we take SharePoint as an example, you have a SharePoint library, and a user may have access to a SharePoint library. But the individual items within that library, they may not have access to. So those items are resources. And you would use resource-based authorization to access those. Everything is based in DI because all of .NET Core or ASP.NET Core is DI-based. And again, we can filter based on schemes. And if you don't like any of it, you can throw the entire authorization service away and write your own. I have a workshop on my GitHub repo there that is both for 1.0 and 2.0. If you're going to it and you want the 2.0 one, there's a link at the top that will take you to the right branch. If you haven't looked at this yet, I strongly recommend going through the workshop. It takes you through step by step from just logging someone in through authorizing based on username, which you should never do. I think we all know that. Through authorizing based on groups, authorizing based on roles, authorizing based on claims, all the way through to resource authorization. And then there's a little exercise at the end so you can prove to yourself that you've learned something. So let's talk about policies, requirements, and handlers. Policy is just a way of naming something. When we try and enter Microsoft buildings, those of us that are employees have a magical badge that we tap against the little black box and the door opens. So the policy there would be, do they have the magical badge and have they tapped it against the box? So we have requirements like that. Then there are certain doors that we cannot go through. I can't climb up onto the roof, for example. Apparently, I can't even come into the studios here because someone's probably worried about me stealing the cameras. So for those, we have an extra requirement. It's like, can the person actually enter this room, not just the building? And so we set a policy up and we specify our requirements, and every single requirement is evaluated. So if a requirement fails, we're still going to evaluate the rest, so you can do logging or any other sorts of side effects. And if they all pass, then the policy passes. And requirements are simple. They are just an implementation, just a class that implements iAuthOrization requirement. And again, it's a marker interface. So you can use this for parameters if you want, and I'll show this in a little bit. A requirement can have multiple handlers. So we take the I'm not allowed in here because I'm going to steal the cameras requirement. Well, we have multiple handlers. For that, we would use our building access handler, and then we would go off to some sort of authorization list for badge numbers. So 2 requirements for 1 handlers. You have to register your handlers in the DI system. Otherwise, it doesn't work, which is what I tend to forget every time I'm developing a new demo. So if your policies don't work, make sure that your handlers are registered in DI. Here is a simple authorization requirement. Nothing. Nice and simple. Marker interface. Here is our handler. So an authorization handler for office entry requirement. I'm going to implement handle requirement async. I get my context in. My user is on a context. And then I have the requirement that I'm being asked to fulfill. I'm going to do whatever work it needs to take to make a decision to see if I can fulfill that requirement. And if it is, I'm going to call context.succeed. If it fails, I'm going to do nothing, because there may be multiple handlers, remember. So another handler could fulfill this requirement based on the user. And then for policies, when we're adding authorization, we do options.addPolicy. We give our policy a name, and then we add all our requirements. And like I say, we remember to register the handler for the requirement. Now here I have the policy name as a string. To be honest, if you want my advice, you put a static class in the root of your application, and then you have public const strings for each of your names. So then you're just using that constant value, both when you're creating your policy and when you're trying to apply it. And let's talk about how we apply it. Well, we're back to our authorize attribute again, and we're just specifying the policy in our parameters. So our building entry requirement has now been applied to our building controller. So we're going to demo this. This is where I have actually tried to show off what little design skills that I have. So you can feel free to heckle via comments, because none of you are here in person, but believe me, people heckle in person when they see my stunning web design skills. So we'll start this up. And then Edge thinks about it a little more. Okay, so building 18 is where I live. Building 25 is where I go when there are security incidents. It's the unhappy building where I have to go and explain what's gone wrong. So building 18 I can get into. So let's try and enter building 18, and this is where I sit. And I've got a bunch of access badges. I have my own. I have David Fowler's, which is the old style access badge because he's too cool for school to update to the fancy new ones. Got Andrew Staton Nurse, who has volunteered to be demoted to Contoso for the purposes of this demo. And here we have a temporary pass, which is what reception gives us when we forget our badges. And then they have to press a magical button and make the doors open. So this is a temporary pass that has expired. And we'll come on to why that's important in a minute. So I'm going into my building. So I can be me, I can enter my building, and that's great. Sign out again, let's go into my building. Fowler can come into my building and generally come and upset me, because that's what he does. We'll sign out again. Andrew, who remember has been demoted to Contoso, well, his badge doesn't work at Microsoft buildings. So our policy is saying, well, is this actually a Microsoft badge? So Andrew can't get in. And temporary badge that has expired, I'm going to click that, and my temporary badge won't work because it's expired. So let's just then also demo the MSRC building. So I'm going to go here, and this is the MSRC war room for serious security incidents. I can get in there, sign out, Going back in again. Now we know my temporary pass isn't going to work, and we know that poor old Andrew, who's been demoted to Contoso, can't work. David does not have access to this room because he'd be argumentative. So it keeps everyone's sanity. If I click on David, whilst David has a valid Microsoft badge, because you could see he could get into building 18, he can't get into the security war room, which is great. I should hide out there more. So let's look at the code for this. Here we have startup, and we are going to, wrong one. I am setting up a room access repository, which we'll come on to in a minute, but because everything is in DI, you can inject your databases into your authorization policy handler, so you can go off to a database and check. I'm going to have a Microsoft-only authorization handler, and then I'm going to have a specific room one. So if I go down and look at my handlers, Microsoft-only handler, there's my requirement, has nothing in it. Microsoft-only handler is going to look for a badge ID. And it's going to look for a badge ID that's been issued by Microsoft. So Andrew's badge, his Contoso badge, must have a badge ID, but it's not from the right people. So when you're evaluating identities, you should be checking the issuer. And my temporary badge is still a Microsoft badge. It's been issued by the right people, but I'm going to check to see if there is any expiry date. There's no expiry date on our normal badges, but there is an expiry date on the temporary badges. So I'm going to look for my access expires on for a temporary badge, and then I'm going to validate that it's still correct. So the badge is still valid. And you'll notice there is no context.fail. We'll talk about what context.fail does in a little bit, but I've got context.succeed. And then for my room access, well, here's my repository of a very horrible list of who can get into what room. And there's can you enter it. In my room entry authorization handler, well, this is going to be a resource authorization because the room is a resource. Resource authorization is going to take the resource that we are authorizing, plus a requirement. So I'm going to get the badge details out. The requirement is going to specify the building. The room is coming as the resource. And then I'm going to go to my repository and see if someone can enter. So it's nice and flexible. And more importantly, you don't have to write your own authorize attribute anymore. Here we can see we are going to specify the Microsoft only policy for all of our buildings. And then when someone tries to exit or enter a room, well, we still get our Microsoft only policy being evaluated. But now I'm going to create a room resource, and I'm imperatively checking whether this person is authorized. And because it's a service, services can be injected in our constructors. And then if I get back an authorization result of succeeded, I'm going to return my view. Otherwise, I'm going to say you're forbidden. And then security comes and drags Fowler out of the building in my dreams. So stunning web design skills, I'm sure we can all agree. Successful evaluation of a handler calls context.succeed with an instance of the requirement. An unsuccessful evaluation does nothing because remember, there can be multiple handlers for a single requirement. So if any of those handlers succeed, then the requirement has been fulfilled. So you don't want to do anything if your individual handler hasn't succeeded. There is a context.fail. It is there for horrific circumstances. It's there for, I've just checked the user has been fired database. It hasn't populated around to all our normal checks. So I'm going to fail no matter what. Even if something else has succeeded, I'm going to override that and fail. But it's not something you want normally. It's user has been fired or my database server is on fire kind of thing. So things to remember. Your handlers have to be registered in DI. And because they're in DI, you can inject repos, everything else. But if you're doing database access, please remember your DI scope. Otherwise, Entity Framework will throw a complete wobbler if you try and add it as a singleton. And check your claims issuer when you are examining claims, just to make sure that someone doesn't have a badge from Contoso. Then the imperative checks, we're evaluating policies in code. You don't have to do it as a resource, but you could just call the authorization service manually. You just inject iAuthorizationService service into your controller or any other class that supports DI. Then you call authorize async, and if it fails, return forbidden result, and the forbidden flow will kick in. You can also use this to adjust UI. This is where people get a little bit upset because there are two schools of thoughts about this. There is one school of thought that is, if you are using a view model, and you should be using a view model, please don't ever bind your EF models to MVC views. You should be setting the access evaluations in the view model, but some people don't want to do that, and they want to adjust. The view inside the view itself. So you can use Razor's DI system. You can do the @inject command. You can put it in view imports if you want to make it globally available, and then you can call authorize async and show and hide parts of your UI based on whether someone is fulfilling a policy or not. But when you are doing that, remember that just hiding something from the view does not restrict access to it. You need to do that check again within the controller method for the part of the UI that has been hidden, because otherwise someone can just type in the URL or submit a form with Fiddler and they will hit your endpoint. Just always duplicate your checks. Resource-based authorization. We had our room as a resource. So the building would have been a container and the room would have been an individual resource. So you can act on properties within the resource once you've pushed it through to the authorization bit. So consider a Word document. The current user could own a Word document because the author property inside the Word document is them, so they can edit it. But you could also have administrators that are allowed to delete Word documents. So you have two checks. You have an administrator, can they do this delete operation? And you can think of the operation as a requirement, or the user can do it. So there are two ways to fulfill it again, but you can act on whatever is in the resource how you like. Here's an example of a resource authorization handler. It looks exactly the same as a non-resource authorization handler, except there's an extra parameter, which is, surprisingly, the resource. So it gets passed in to handle requirement async, and lo and behold, we can do things on the resource properties, and away it goes. And like before, because you want to limit things by schemes, if you have multiple schemes, you don't have to hard code them within the authorize attribute. You can put them in your policy right here. This is the sort of way that we expect you to do JWT authorization for cookie or for web APIs when you normally have cookie auth, rather than doing all sorts of weird, funky stuff based on the path. We're going to come on to protecting your data. Data protection is kind of hard. It's hard to get encryption right. It's even harder to get encryption safe. So what we did was, well, we had MachineKey.protect and MachineKey.unprotect before, and that was too simple, because your machine key was stored in your config file, and if you had multiple machines, you had to swap them over all at once, although everything would break. And if you have persisted data, there was no way to use two machine keys and check either one. It was horrible. And so we threw it away. This does mean you have to do a little bit more work. But data protection is a one-stop shop for encryption and signing. There's no more machine key. We've aimed this at ephemeral data, so data that you don't mind if you can't decrypt it again. So, login cookies. If that can't be decrypted again, a user just has to log in again. It's no big deal. But if you do want to use it for your own data, then you can take steps to make sure that you persist your keys, and then it's up to you to back them up properly. So it removes the ability for you to shoot yourself in the foot. We are choosing algorithms for you. We are choosing rotation for you. We will rotate your keys automatically, so they're not used for, it's either 30 or 90 days. I cannot remember. It's on the next slide, I believe. We provide isolation for applications. You can have multiple applications pointing at the same key ring, using the same keys for encryption, but one application cannot decrypt another application's data. And then we have isolation based on purposes. So if you want to protect a credit card, not that you should be storing credit cards, PCI standards say that you can't, but it's a good example. If you want to protect a credit card and a user's address, you would have different purposes. So the encryptor that is created for protecting a credit card cannot be used to decrypt a user's address, and vice versa. We do make an attempt to figure out where to store keys based on your app platform. We know what to do if you're on Azure websites, for example. We don't know what to do if you're on Linux. So you're going to have to configure it because Linux really doesn't have a good key isolation story, so you need to do some work there yourself. And if you want to write your own, if you want to store it to SQL, if you want to store it to MongoDB, whatever, you can write your own. It's incredibly simple. You are basically storing a piece of XML that we give you, and then you have one other function, which is tell me all the keys that are in your database or in your store. And that's it. It sounds hard, it's not. And we have the ability to support custom algorithms. Most of you, this is not for you. Do never ever write custom encryption algorithms. This is basically for Russia. The Russian government mandates that you should use an algorithm that they are happy with, that is theirs. So you can write a plugin for Ghost, if you so wish. Here are our defaults. Here was the next slide. So we are creating a 512-bit master key. We are rolling it every 90 days. These are the defaults that your security people will want to know and that you should never have to care about. If things change, if suddenly someone has cracked HMAC SHA-256, which will be a horrible day, we're still getting over SHA-1, to be perfectly honest, we can change this in our code and it will flow upwards. It'll still be able to decrypt your old stuff, and then when you keep using it, it will magically use the new stuff. So key stores. Azure Web Applications have a special synced folder. It does not work over Azure slots. There is no concept of a storage common between slots, but it will work if you spin up one instance, say in US West, and then you spin up another one in US East, and then you go across to Amsterdam and you go across to Dublin. The keys will flow magically. If you're running underneath IIS with the user profile, we default to the registry, and then we use Machines DP API, and we ACL it. If you're in IIS with the user profile, we stick it under app data, and again, we use Windows DP API to protect it. If you're a Linux, the default that we have, the only thing that we can do is in memory, and then we discard your keys when your application stops. But you can set it to just use a folder on disk. And then it's up to you how to protect that folder. So protections for Windows, we can use DP API NG. You can use an X509 certificate, or you can just leave them unencrypted, which is a really silly thing to do. We also have blob storage for key stores. We have Redis, where you don't really care whether it gets thrown away or not in case the cache gets emptied, but you can configure Redis for permanent caches. And then for Azure Key Vault will be coming in version 2.1, so you can hook it up to your Azure Key Vault. We will create a key, and then it will get magically rotated, and away it goes. You can use data protection yourself. You create a data protection provider. You inject it into your controller, and then you create a data protector from it, and you set a purpose, and purposes, like I say, are used for isolation. In ASP.NET Core, you just do services.add data protection, and then you call .protect and .unprotect. There's no specifying keys, there's no specifying algorithms. It's just like, here's what I want you to protect, go do your magic, and then here's the protected stuff, unmagic it. An example using the ephemeral data protection provider, the one that gets thrown away. Nice and simple. I'm going to create a protector with a purpose. It's not very exciting. So purpose strings, they are, as I've said, a way to isolate individual elements within an application. So they are used to sort of derive keys from the master key. So we can create protector for authentication. It can't be used to unprotect data that has been used with a data protector. And it gets a little bit more complicated than that. You can keep creating protectors nested. So I could have an authentication protector, and then I could, underneath that, create a protector for cookie, or a protector for bearer. The parent protector can decrypt the things that are underneath, so cookie and bearer, but cookie cannot decrypt bearer, and bearer cannot decrypt cookie. So there are some caveats for purposes. Do not use user input for this, because then obviously an evil person could quite happily use whatever they want as a purpose and perhaps bypass your app isolation. We like the idea of you using namespaces, classes, and versions. So the way to configure data protection, select your key store, select your encryption mechanism for the key store. You can change the key expiry policy and set an application name. Now, we said that we automatically isolate based on application. If you don't want that, you just have to set the same application name within 2 applications or 3. Here's how we persist to a file system. There's how we choose a certificate, or you can pass in a PFX, and we're setting our application name. So we have some compatibility pieces for this. It's not back compatibility. What we have is forward compatibility. So what you do is you take your old app, and if it's running on .NET Framework 4.5.2, and you're against .NET Core 1, or 4.6.2 against .NET Core 2, we replace the machine key.protect and machine key.unprotect with the new bits. So you have to configure the key rings and everything else. And then when your old application writes a forms authentication cookie, your new application can share it. We're not doing back compat. We're dragging your old applications forward, frankly, because it's safer and more secure. So that is pretty much it with my exciting demo. So I've got some questions. Lena says, is there going to be a template for identity for Web API? Yes, there will be. I believe there's the start of it in the identity repo. You can go take a look. But there is definitely going to be a template. So you can have an API app. We will have an HTML page that probably uses Angular to just go talk to the OIDC bits and pieces. Brian says, are there any templates out there that shows how to use .NET Core with Azure AD B2C? Yes, the Azure AD B2C people have templates for this. Integrating it with SPA frameworks like Angular, again, I'm going to point you to the Azure B2C people because they have a bunch of demos. Okay, then there is a next question, which can scroll up. I would see the next question. Oh, there we go. What about Active Directory LDAP support? Okay. We're thinking about bringing back the LDAP libraries. .NET Core has it on their backlog. I could not give you a time scale for it. There are third-party LDAP libraries out there right now. Someone ported the old Novell one from .NET across to .NET Core. So you could use that in concert with the cookie bits and pieces to then persist your identity. But we'll have a supported directory services namespace at some point in .NET Core. I don't know if it's coming in .NET Core 2.1 or 2.2. I believe there was some discussion yesterday of what was coming up and a desktop compatibility package. You might want to go back and look at some of the .NET Core presentations from yesterday, and they may cover it. But it is coming. Mike Renz asks, if Configure Services adds 2 authenticators, OpenID Connect, that is automatic, and JotBearer, that is not automatic, how does Kestrel or IIS know which authenticator to use? Okay, so yeah, okay, this is difficult. The automatic one runs automatically. Tautology, sorry. The JotBearer one does not. We cannot tell which one to use. You have to tell us either via your policy, and we can skip back to, actually, let's see if we can find it again. If we skip back, we have the authorize with active authentication schemes. Where are you? Configuring. So here we go. We have this one. Let's zoom it in. We have authorize active authentication schemes equals bearer. So you would put that on your API endpoints, on the controllers that you want to have Jot. Everything else will use the automatic one when you do authorize. If you want to use both, well, this active authentication schemes is a comma delimited list. And you can do this in a policy as well. There's a property on the policies if you want to express it in code rather than inside an attribute. And you can do them both that way. There's no way for us to tell what to do, especially with OpenID Connect. It's an actual specific gesture that gets done in code. We don't know if something is a Jot bearer token, because then we'd have to parse it, and we can't parse it because it may be encrypted, and bearer is just meant to be an opaque string. So you have to make the decisions yourself, either in the authorize attribute or in the policy. And I hope that clears it up. If it does not, you can tweet me as @blowdart, and I will try and answer it in a little bit more detail. Do we have any other questions? I don't believe so. So with a minute to go, I think that's it. I hope this has given you a good overview of why we change things and how you can make use of it, and also where we're going. Don't forget, this is all open source. If you have problems, you can flag issues in the identity repo underneath the ASP.NET org, and then you will get me looking at them and then making one of the developers answer, because they know more than I do. I'm just a PM. I take all the responsibility for the work and all the glory. They do the hard stuff. Thank you very much for watching. I hope this has been useful, and enjoy the rest of your conference.